All right, so we've been talking about linear equations, linear functions, and we've been putting them in slope-intercept form, right? There are other forms out there, standard form, and there's also something called point-slope form that we're not going to work a whole lot with. But we want to talk about standard form this time. So by the time we're done, we should be able to write a function in standard form. We should be able to graph horizontal and vertical lines. We're going to take a look at those again. And we want to be able to graph using x and y intercepts. And that's what standard form is kind of useful for. And there are your standards. Now, standard form looks like this. So compare and contrast this with slope-intercept, right? So slope-intercept form, you know this, is y equals mx plus b. You've been using that for quite some time now. So standard form is different. Slope-intercept form, you get y by, you isolate y. You have x, an x term and a constant separated from the y in your linear equation. Standard form has the x and the y term on one side and a constant on the other. So that's the difference. They both have x and y's and the constant. It's just where they're located in the equation. Now here, a, b, and c are just real numbers, not a big deal. But I do want to make sure that if you have something like 3x plus 4y equals 10, that's standard form. But if you had 3x plus 4y minus 10 equals 0, that is not in standard form. You have to actually add 10 to both sides to get that constant away from x and y. Okay? But standard form looks like this. X and y on one side, constant on the other. So for example, 2x plus 3y equals 6 is in standard form. To graph this, if it's in standard form, we've only graphed in slope-intercept form so far, so we need to put this in slope-intercept form. And we've been doing this, right? We move the x term first, and so we get 3y equals, now 6 and negative 2x we can't combine, they're not like terms, so we just bring them down, and we divide through by 3. And so we get y is equal to negative 2/3 x plus 2, and then we go graph, right? We're at 2 on the y-axis because 2 is the y-intercept, and then we use our slope. Our vertical change is negative 2, so we go down 2, and our horizontal change is positive 3, so we go right 3. And then we're ready to graph our line. Okay? Now, domain and range, not on your notes, but in here, and it's something that we need to start talking about, because we're going to start talking about other functions that domain and range is pretty important for. So, domain and range. Domain, remember, are the x's. They're the inputs of your function. From a graph, what you can tell, what you're trying to figure out is what inputs are allowed, right? What am I allowed to put into the function? Well, this is your x-axis, this is your y-axis, so for a domain, this is the domain or the x's, we're really looking to see, can I get to the graph if I'm standing on the x-axis, either going up or down, right? If I'm standing at negative 10 on the x-axis, can I look up or down and see the graph? Well, I can look up and see it. At negative 6, I can look up and see it. At negative 1, I can look up and see it. When I get all the way over to 7, I have to look down to see it, but I can still see it. So that means all of these values on the x-axis are allowed to be inputs. There are points, let's say it another way, there are points on this graph, on this line, where the x-coordinate can be one of these values. There's a point on this line where the x-coordinate is negative 10, because I can see the graph at negative 10, right? If that's the case, then our domain, and because the line keeps going out, up and to the left forever, down and to the right forever, it's basically going to extend left and right forever. That means every value, every possible value on the x-axis is part of the domain. So the domain goes from negative infinity to positive infinity, and this is how we write it in these parentheses. It's called interval notation, negative infinity to positive infinity. Okay? Range, it's the same game, only now it's if we're standing on the y-axis, can we see the graph looking left or right? So here we can go this way, here this way. Down here we have to look right, but we can still see it. That means that there is a point on this line that has each and every value. There's a point on this line that would have each and every value of the y-axis. In other words, there's a point on this line that has a 7 as a y-coordinate. Same thing for every other value on this y-axis. So the range is also negative infinity to positive infinity. It extends up and down forever, so it goes from negative infinity to positive infinity. Okay? That's how domain and range works. Now, got another standard form of an equation here. Work on getting y by itself, graph it, and then give it a shot. Give domain and range a shot. Stop the video and I'll walk you through it when you're done. Alright, so we're working on getting y by itself. We're going to subtract the 5x first. Okay, got to move that x term first. And we're going to divide through by negative 2. And so y is going to be equal to 5 halves x minus 5. Okay, go graph. We're going to be down here at negative 5 on the y-axis. The vertical change is positive 5, so we go up 5. It's positive. The horizontal change is positive 2, so we go right 2. And there's our graph. Okay, now, quicker look at domain and range. The graph, although it is more up and down than it is left or right, it does go to the down and to the left, up and to the right. So it will eventually span left and right forever. So that means that our domain is negative infinity to positive infinity. It will go down forever and up forever because it's a line and lines extend forever. So our range is going to go negative infinity to positive infinity. And now we're done with the domain and range. Okay? All right. Try this one on your own as soon as we work it down to where it makes sense. Now, if you have a standard form like this, and you're trying to get it in slope-intercept form, where you have these fractions for coefficients, my recommendation to you is to get a common denominator and then drop the denominators. We're going to clear the fractions. The least common denominator is a 6. So if we multiply 7/3 to make the denominator a 6, we've got to multiply by 2, so we get 14/6. To make 7 halves have a denominator of 6, we've got to multiply by 3. And to make 7/1 have a denominator of 6, we're going to multiply by 6. Then we're going to drop the denominators. And so we have an equation that looks like 14x plus 21y equals 42. Now we have something that we can work with. Get y by itself here, graph, and come up with the domain and range. And you should have ended up with y equals negative 2/3 x plus 2. There's your graph. It should look just like this. You should have a point on 2 and a point on 3. Point on 2 on the y-axis, point on 3 on the x-axis, and then graph your line, your domain and range, negative infinity to positive infinity for both. If you're not getting that, make sure you come in and see me during STAR and we'll figure it out. Okay, now, move on to horizontal and vertical lines. Horizontal lines. A horizontal line has a slope of 0. Why is that? Remember that at this horizontal line, slope is supposed to take us from one point to the next. Well, those 2 points on the horizontal line, there is no vertical change, and vertical change is your numerator. But there is a horizontal change, and any time you take 0 divided by a number, you just get 0. So the slope is 0. Obviously, these horizontal lines are not going to cross the x-axis, and therefore that leads us to what the equation of the line should look like. Well, first of all, we know that in slope-intercept form, y equals mx plus b, if the slope is 0, which is what it is for a horizontal line, 0 times x is 0, 0 plus b is b, so our equation simplifies down to exactly what this says. Y equals, and then whatever the y-intercept is. Remember, b is the y-intercept. So for this top line, your equation would be y equals 4, because that's where it crosses the y-axis. Down here, your equation would be y equals negative 2, because that's where the red line crosses the y-axis. Okay? If your line is not going to cross the x-axis ever, then your equation should not have an x in it. Okay? And you can look at it the other way. If an equation does not have an x in it, then it will not cross the x-axis. And the only type of line that does that is a horizontal line. Okay? Now, kind of the same approach for vertical lines. They have an undefined slope. Now, why is it undefined instead of 0? Because if I want to go from one point to the next, the vertical change, there actually is one. The horizontal change is 0. And anytime you divide by 0, you can't do that. That's an undefined quotient. Okay, so that's why the slope is undefined. Now, not so easy to figure out why the equation is x equals a, but we can use the same common sense approach from horizontal lines, and that's this. A vertical line is not going to cross the y-axis, so your equation should not have a y in it. So what we do is we just we make the equation look like x equals whatever the x-intercept is. X equals 2 for this guy. X equals -3 for this guy. Okay? All right, let's put this to use. First one, y equals 4. Well, there's no x in it in the equation, so we're not going to cross the x-axis. That means it must be a horizontal line going through 4. Now, domain and range. The graph extends left forever and right forever, so the domain is going to be -infinity to +infinity. However, the graph does not go up and down forever. Right? As a matter of fact, you can't go to any value on the y-axis and see the graph looking left or right until you get to 4. Then you can see the graph. 4 is the only value, so that means the range is just 4. The only output that you're ever going to see is a 4. And we put 4 in brackets. That's just how we write it. We'll talk a little bit more about that when we get to absolute value functions later. Okay? Now you try to graph this one. Remember, we have to know what x is equal to, so we got to get x equals. But stop the video, try it, and I'll walk you through how to do it in just a second. Okay? So, got to know what x equals. I'm going to subtract 3 from both sides. So x is equal to -3. Now, there's no y in the equation, so it's not going to cross the y-axis. That means we're looking at a vertical line through -3 on the x-axis, just like that. Now, domain. This graph does not extend left or right forever, so it's not going to be -infinity and +infinity. So we have to look at the x-axis. The x-axis, the only place where you can see the graph is here at -3. So the domain is -3. The range, the graph does extend up and down forever, and so the range is -infinity to +infinity. Those are all your possible outputs. -3 is the only input you're going to put into the function. It's the only one that's allowed. Okay? All right. Got one more to try here. Stop the video, give it a shot, and I'll show you what you should get. And you should get this. It's a horizontal line going through -3 on the y-axis. The domain is -infinity to +infinity, and the range is just -3. If that's not making any sense, make sure you get in here and see me so we can figure it out. All right. Now, x and y intercepts. We know at this point that a y-intercept is where the graph crosses the y-axis. So it makes sense that an x-intercept is where a graph crosses the x-axis. Okay? Now, in order to talk about how to use these, we need to understand what it means to cross the y-axis. So the graph crosses the y-axis here at 2. What are the coordinates for that point? Well, the coordinates for that point are 0, 2. If the y-intercept is anywhere, well, a y-intercept is going to be on the y-axis. It can be anywhere on the y-axis. A line could cross at 1, and the coordinates would be 0, 1. It could cross at -2, and so the coordinates would be would be 0, -2. There is a common theme here, and that is this. To be a y-intercept, a point has to be on the y-axis. In order to be on the y-axis, the x-coordinate has to be 0. So for an x-intercept, x is always 0. We're going to use that idea in just a second. Now, same thing for an x-intercept. Whether it's here, or here, or here, the common theme here would be that the y-coordinate is always 0. So that means that for an x-intercept, y is always 0. And so that gets us to how we're going to use this. Okay? Now, here's another function in standard form. Before, we got y isolated, so we had it in slope-intercept form, and we can go graph. We don't have to do that. We can go find the y-intercept and plot that point, and then we can go find the x-intercept and plot that point, and that would give us our 2 points to draw a line through. What we just talked about, in order for a point to be a y-intercept, it has to be on the y-axis. In order for it to be on the y-axis, x has to be 0. So we're going to literally plug in 0 for x, because we know that's what it has to be. If we do that, we don't need that parentheses. 2 times 0 is 0. 0 plus 5y is 5y. So in essence, we've taken the original linear equation and we've kind of ignored the 2x. We've got 5y equals 10 divided by 5, and y is 2. So that means that the coordinates for this y-intercept is 0, 2. So I go over to 0, 2 and plot a point. Now, same thing for the x-intercept. If you're going to be an x-intercept, that means you have to be on the x-axis. In order to be on the x-axis, y has to be 0. So we can take 2x plus 5 times 0 and set it equal to 10. 5 times 0 is 0. 2x plus 0 is 2x, and so we get 2x equals 10. So in essence, we've kind of covered 5y up. And we just have this equation, 2x equals 10 divided by 2, and x is 5. And so the coordinates for the x-intercept is going to be 5, 0. So we go to 5, 0, plot a point there. Now we have our points, so we can graph our line. And we're done. This idea of plugging in 0 for x for the y-intercept, or plugging in 0 for y for the x-intercept, is kind of like us covering those up. And so very often you hear this called the cover-up method. To graph a line using x and y intercepts, we use the cover-up method. Covering up because that means we're plugging in 0 for whichever variable we're covering up. Now, domain and range, the graph extends left and right forever, so our domain is negative infinity to positive infinity. Our range, our graph extends up and down forever, so again, negative infinity to positive infinity. Okay? Now, a little bit faster getting there. The y-intercept, x is going to be 0, so we can ignore the x term. We get 6y equals 18 divided by 6, and 18, or y is 3. The x-intercept, now we're going to go back to the equation and cover up the y, and we get negative 3x equals 18 divided by negative 3. So now our y-intercept, our coordinates are 0, 3. Our x-intercept, our coordinates are negative 6, 0. 0, 3 is right here. Negative 6, 0 is right here. And we graph our line. Our line extends left and right forever, so our domain is negative infinity to positive infinity. Our graph extends up and down forever, so same thing. And so we're done there. Okay? All right. Try number 9 here. Stop the video. I'll walk you through how to do it once you're done. And we'll check your answer. All right. Well, first of all, did you realize this was not in standard form? We have to have x and y on one side, constant on the other, so we had to subtract 5y from both sides to make that happen. If you didn't realize that, go ahead and stop the video now and get that done. It might change what you do, so it might change your x and y intercepts in your graph, so go ahead and change that as well, and then start this back up to see if you're right. All right, to find the y-intercept, we're going to cover up the x, get negative 5y equals negative 20. Divide by negative 5, and so y is going to be 4. Now, to find the x-intercept, cover this up, we get negative 4x equals negative 20. Divide by negative 4, and x equals 5. So our y-intercept point is 0, 4. Our x-intercept is 5, 0. So let's go plot these points. There you go. Okay. Now your domain, again, your graph extends left and right forever. So negative infinity to positive infinity. Your graph extends up and down forever. So negative infinity and positive infinity. Make sense? All right. Last one here to graph, y equals 2. To find the y-intercept, cover up the x. Wait a minute, this doesn't have an x. So stop right now. If the equation does not have an x in it, that means the graph is not going to cross the x-axis. So it's not going to have an x-intercept. It's going to be a horizontal line through 2. It's only going to have a y-intercept. And so there's your graph. We can talk about domain and range. The graph extends left and right forever, so it's going to go negative infinity to positive infinity. It does not go up and down forever. As a matter of fact, as far up or down as it goes is 2, and so 2 is your range. That's it. Okay? All right. Now, the idea of x and y intercepts. We can put those to use in the real-world application here. In a pickup game of basketball, baskets are worth either 2 or 3 points, right? So if Mrs. Hull scored 24 points, write and graph an equation that represents the numbers of 2s and 3s she hit in the game. And then list 3 possible combinations. So my question is this. If you're playing basketball and you've got 24 points, is it possible that you could have hit all 2s? Sure. Is it possible that you could have hit all 3s? Sure. Could you have had a combination of 2s and 3s? Absolutely. So we need to figure out what possible combinations there were. Okay? Well, we don't know how many 2s she hit. We don't know how many 3s she hit. So those need to be our 2 variables. X is your number of 2s. Y is your number of 3s. She scored 24 points. Those are her total points. Well, how do you figure out her points? Well, we need points from the 2s plus points from the 3s, and that has to equal 24. Well, to find out how many points she got from 2s, we got to take the number that she hit and multiply it by 2. Same thing for the 3s. We have to take the number that she hit and multiply it by 3. So 2x plus 3y equals 24. Now that's in the standard form, and we can go graph a line. We have a graph over here. And since we define y as the number of 3s, that's going to be our y-axis. And we defined x as the number of 3s. And our x-axis is the number of 2s. So we can graph this. We don't have the negative side of the x-axis, the negative side of the y-axis, because we can't hit negative shots. That's what x and y stand for. So, all right, so for the y-intercept, cover up x and get 3y equals 24. Divide by 3 and y is equal to 8. For the x-intercept, cover up y. You get 2x equals 24. Divide by 2, and x is 12. So, y is equal to 8. So go up to 1, 2, 3, 4, 5, 6, 7, 8 on the y-axis. And then x is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 12. This is 8. And we have to draw a nice straight line. Okay? Now, possible combinations. What does this mean? Well, this point is 0, 8. The x intercept point is 12, 0. That means that she could have hit, these are 2s, these are 3s, she could have hit 0 2s and 8 3s. Or she could have hit 12 2s and 0 3s. So really any point on this line should give us a combination of 2s and 3s, including this point right here, which goes through a grid corner. We're always looking for grid corners, which means that 1, 2, 3, 4, 5, 6 2s, and 1, 2, 3, 4 3s should work. Well, 6 2s would give you 12 points. 4 3s would give you 12 points, and that certainly adds to 24. That'd be a way to check your work. Okay? Got another story problem here that we can walk through. Mrs. Coyne decided to buy Chick-fil-A for her star. She took orders for chicken sandwiches that cost $2 and chicken nuggets that cost $3, and she spent $48 on the order. Write an equation to model this situation and find 3 possible combinations of the number of chicken nuggets and chicken sandwiches she bought. Okay? Try this out. Try to come up with the equation, graph the line, and find the points that would give you possible combinations. Stop the video, give it your best shot, and then you can start it back up and check your work. And your problem should look like this. So walk through it. If there's any issue getting to this, come see me during STAR and we'll walk through it and figure it out together. Okay? Homework's out in Canvas. Give it a shot. And we'll go over any questions you have next time. All right?